morning, good afternoon, and good evening from wherever you are watching from in the globe. You are welcome to Prince Maths Clinic. And today, we shall be considering these following equations. The first one is a simultaneous equation that is in form of logarithm, and the second one is just a logarithmic equation. Now, my encouragement is this. I do advise students that whenever they see any math question, they should not panic. All you need is apply the principles and you will see that question crumble like piece of cake. Now, let's go ahead with the first one. Now, what's the question? We have two logarithms here. Log x base 2 minus log y base 2 equal to 2 and log base 2 x minus 2y equal to 4. Let's call this the first equation. Let's call this the second equation. Now, from the first equation, since the bases are equal, we know that from this law, we have a law that says when a log have the same base, let us say log x minus log y, as long as they have the same base, I am free to say log x over y base a. That is to say the first log subtracting the second log, right? The first one should be the numerator, the second one should be the denominator, all sharing the same base. So I'm going to use that same rule to dismantle this first equation. And the ESI is going to look like, I'm going to say from equation 1, log x over y base 2 is equal to 2. Now, I can now convert this now from logarithm to indices. And we know that when you have a log like 10 base 10, we usually say it's 1, right? Or any log to a base, we call it 1. Now, to convert this to indices, just say this base carries this power, 10 to the power of 1 equals to 10. The same way, if I have log 1 to any base is 0. So I can say 10 to the power of 0 gives me what? 1. Now that leads us to define logarithm. Logarithm is actually the power to which a base can be raised. That's what logarithm entails. So I will convert this now from indices, from log to indices, by saying x over y equals to 2 to the power of 2. And 2 to the power of 2 is 4. Therefore, x will now be what? 4y. Call this equation 1. Then we have a second equation there. What's that equation? The second equation says what? Log x minus 2y equal to 4. So if I substitute the value I have for x to be 4y, x is Simbi, 4y is Kunle. It then means that both Simbi and Kunle can go to the same event. They have equal weight. So what it then means is that Kunle is going to replace Simbi in this equation. Simbi is x. Therefore, this will look like this: log 4y minus 2y equal to 4. Now, let us further simplify. Now, minus 2y gives us what? 2y. Therefore, I'm going to have log 2y base 2 equal to 4. Therefore, I can say my 2y will now be 2 to the power of 4. And what is 2 to the power of 4? 2 times 2 times 2 times 2, which is 16. Therefore, my 2y will be 16. And if I divide both sides by 2, I will get the value of y to be 8. Then recall that our x from equation 1 is 4y. Therefore, our x will be what? 4 times 8, which is what? 32. Now, we can verify our result by substituting the values that were found for x and y back into any of the equations. So let's pick the first equation. The first equation is log x, and our x is 32 base 2 minus log our y is 8 base 2. Let us see if it's going to give us 2. So 32 can be expressed with a what? With a base of 2 in this form, because 2 to the power of 5 gives us 32 minus, same way 8 can be expressed as 2 to the power of 3. And we know from this rule that when a base carries a power, it's going to become, the power will multiply the log. This becomes c log b base a. So we are going to use that here. So this becomes what? 5 log 2 base 2 minus the same thing, 3 log 2 base 2. And when a log and a base are the same, it's 1. Whether log 1 million base 1 million, log a base a, it becomes what? 1. So this becomes 5 times 1 minus 3 times 1. 5 times 1 is 5. 3 times 1 is 3. So therefore 5 minus 3 gives us 2. So that means this is correct. So let's try the second equation. Let's just substitute it in the second equation and let's see what we are going to obtain. Now, log the first equation, x, our x is 32. Our y, 2y, means 2 times 8, which is 16, base of 2. Let's see if it will give us 4. Now, 32 minus 16 is 16. And 16 can be expressed as 16 can be expressed as 2 to the power of 4, which becomes what? 4 log 2 base 2. And you know that when a log and a base are the same, it becomes 1. So this becomes 4 times 1, which is 4. So it means that our values are correct. Now, let's attempt the second question. If 2 log y base 3 plus log x squared base 3 equals to 4, we should find the value of y. Let's attempt that. Now, this 2 is multiplying this. So, based on the law I introduced to you in the first question, I'm going to bring this 2 down here to multiply this as well. So, I will have 2 log y base 3 plus log x squared base 3 to be equals to 4. Therefore, 2 log y base 3 plus this 2 comes down, so this becomes 2 log x base 3 equals to 4. Now 2 is common with them. I'll bring out that 2. So I have log y base 3 plus log x base 3 all equal to 4. Now what do you notice? The bases are the same, and based on the rules of logarithm, once I have 2 values that have the same base, it permits me to multiply them. So x times y become xy. That's what I'm going to use here. So therefore, this becomes what? 2 log xy. Permit me to say xy, right? Xy is equal to yx. They are the same. It's just like saying 2 times 3 is the same thing as 3 times 2, no matter the position, whether 2 comes first or 3 comes first, you get the same result. So equal to what? 4. Now do this, put it in brackets because the 2 is shared by the y and the x. So what do I do next? Watch what I'm going to do. I'm going to say log xy squared base 3 is equals to 4. So I want to convert this to indices. So what will it be? So my xy squared is equals to 3 to the power of 4. And 3 to the power of 4 means 3 times 3 times 3 times 3, which is 81. So therefore, xy squared is equals to 81. But if I want to get the value for xy, I take the square root of both sides. So the square, we cancel the square root. And we know that the square root of 81 is 9. So therefore, xy will give me 9. So the question asks us to find the value for y. So therefore, y will become 9 over x. That is it. Now you can substitute the value for y back into this equation and confirm the result. Let's do that. Substitute 9 over x for y back into this equation. So it becomes 2 log 9 over x base 3 plus log x squared base 3. Let us see if it's going to give us 4. Now, I will solve it like this, just the way I analyzed. I'll bring the 2 down here to multiply the log plus 2 log x base 3. Now I'll factor out 2. Then I have 9 over x. Now because the 2 logs are multiplying, are adding each other, I'm free to multiply by x. So what do you have? Your x will cancel your x. So I have what? 2 log 9 base 3. Now I know that 9 is the same thing as 3 to the power of 2. Then I'll bring this here again. So this becomes 2 times 2 log 3 base 3. 2 times 2 is 4. And log 3 base 3 is 1, because the log and the base, when they are the same, it turns to 1. So 4 times 1 gives us what? 4, which is the value obtained. So therefore, it means that our solution is correct. So that brings us to the end of today's class. So I would plead that you kindly subscribe to this channel. Click on the notification icon so that you can see other videos as they drop on the channel. And also share this video with your friends, family, and loved ones, and your classmates as well. And together we will all enjoy simplified maths. Thank you.